Okay, now that you know the concept of a linear function, let's complicate a little and learn the concept of a nonlinear function. Once again, let's use an example. Imagine that you have €1 today and you want to deposit that euro on a bank to get some return. Imagine that you agree with the bank on a rate of 5%, so then you know that in the next period you will get €1.05. If you keep doing this, for example, in the next period you will get €1.10. We can write this relationship in a mathematical expression. In this case, you will write the money that you will receive in the future will be equal to 1 that you have invested in the bank times 1.05, the rate at which you are compounding your money, to the power of the number of periods that you are willing to wait to get your money back. Well, this is an example of an exponential function. But you may be asking yourselves, isn't an exponential function associated to that little letter e that is usually called the number of Neper? Yes. Well, if you check in your calculator for sufficiently small rates, in this case, e to the power of 0.05 will be approximately equal to 1.05. Let's verify this. So e to the power of 0.05, yes, it's indeed approximately equal to 1.05. Therefore, we can put this mathematical expression as the money that you will receive in the future equal to 1, the euro that you have invested, times e to the power of 0.05, the rate that you have agreed with your bank, times the number of periods that you are willing to wait until you get your money back. Actually, you can see in graphical terms that these two expressions are very similar, as you can see in the slide. Now, imagine that instead of calculating the value that you will have in the future, you want to check what is the time that you have to wait until you achieve a certain value. In order to do that, you apply the log to both sides of the equation. Right? Now, using the properties of the log, you know that this is equal to log of 1 plus 0.05 t times log of e. Now, we know that log of 1 is equal to 0 and log of e is equal to 1. So, in the end, you have log of y equal to 0.05 times t, or turning this around, you have that t is equal to 20 times log of y. So now you can also check in your calculator that 20 times log of 1.5, for example, it's equal to approximately 8. So in order to get 1.5 euros in the future, you will have to wait 8 periods. Finally, in graphical terms, you can observe that the graphic of this expression is the inverse of this expression.